Hello everybody, today's tutorial explains how to do an automatic TCG curve using the TCG, DAC and DGS wizard. The TCG or time corrected gain calibration should be the last calibration that you set, since the others could affect the signal response of your configuration. The purpose of this calibration is to equalise the amplitude of the response from a reflector for all of the angles at different depths. This calibration is meant to counter the attenuation of the signal response of the sound propagation inside the material. For this calibration, you're going to need a Veo Plus or Prisma, a probe and cable, and a navship block or equivalent TCG block. We are using the same wizard principle as shown in earlier tutorials. In this example, we select a 2.25 meg probe and we add a 3D view to our inspection setup. As you can see, all the calibration markers are green and the TCG is the last calibration to be set. In the Calibration tab, we are going to select the TCG, DAC and DGS menu, and then the TCG as a reference curve, which is the most commonly used. There are three modes available to generate the curve. The automatic calibration will generate the TCG curve using the extraction box. This mode is usually faster, easier and more precise, so we're going to select this one. Once the type and mode of the curve have been selected, we are entered into the wizard manipulation section. You can change your general inspection parameters in the first step of the TCG wizard. In the next step, you can set your gain reference and curve amplitude reference with the Set Ref Gain and Ref Amplitude button. Make sure to maximise the reflector response before setting it as a reference. The next step is for the extraction box dimensions and desired depth jumps between reflectors. In our case, every reference reflector has a spacing of 6.25 mm. Once the extraction box parameters are set, we can sweep the first reflector of the TCG block. The red curve is the maximum amplitude response of the reflector within the extraction box for all of the angle beams. When all angles have passed the reflector, we can apply the TCG at the reflector. This will create a gain compensation on every angle beam to equalise the signal response. If we sweep again, we can see that the signal has been compensated, but it still is outside of the inspection tolerance. This step is an iterative process, which could require a few trials before reaching the required gain compensation. In case of bad manipulation, the gain compensation could worsen the signal. In this case, there is an option called Reset TCG Calibration, which cancels the gain correction. The coupling and the probe orientation between the wedge and the part are crucial parameters. If inconsistent, it will be necessary to repeat the process. It helps if you use a guide for your probe to ensure the probe and block orientation remain stable during the sweeping step. Once the signal is within the tolerance, we can do the next reflector. Now that the coupling and the probe relative positions are optimised, the second and third reflector should be easier. The second and third reflector only need one iteration to enter within the TCG curve tolerance. The last step is to validate the obtained curve. Every reflector on every angle should fall within the tolerance of 80% signal response. We should also see that every angle has a distinct TCG curve. Once completed, all the calibration markers will be green and the signal response for a given reflector would be the same regardless of its depth, distance from the wedge or the angle beam orientation. We hope this video has been useful. Thank you for being with us.